This video is an example how to analyze a half-wave rectifier with microcap 12. Okay, first we need the diode. Again, I'm picking up one quite general one, which is widely used, but of course you can pick up any other components if you want to. And then I'm putting it somewhere around that place is good enough, like anyone else, and I need some more components. The next one I pick up is a resistor. 1K again is a good value for that one. Of course you could put whatever you want to. And the last component that I need is a sine wave source, which can be found from here. And normally those values that you can find from the library are not convenient. You have to modify. For example, here I'm changing the frequency from 1 megahertz to 100 hertz, and also the amplitude from 1 volt to 5 volts, and I'm happy with these values. Okay, then I have to connect these components together. It's quite simple. The last thing I need here is the ground. Always you need the ground, you don't forget that one. This program needs a zero level where to compare all the other voltages that can be found in the circuit. Then I need to analyze it. Transient analysis is a good pick one for this one, and I can see that those values that I had in my window are not great, but I can change it. First I have to change the time window, which is obviously too short. I'll change that to 100 millisecond, and I'm running it again. It looks better, but that looks quite ugly. The reason is that I have so few points. I have to add more points to get it, well, more beautiful. 10 microseconds as one time step, and you can see that the result is a lot better. And my rectifier is letting the positive side go through and it's blocking the negative side. But if I am turning my diode vice versa, I'm flipping it, I'm putting it back, and I'm doing the analysis again, and I can see the difference this time. Instead of passing through the positive side, I am now passing through the negative side.